Now for this one here, we have a couple of fractions. So let's just see what each one has to say. Let's say, for instance, for this one here, we cannot divide by 0. So this piece is telling us that x cannot be positive 1. This piece is telling us that x cannot be negative 6. These individual numbers are bad. And so I believe these are the only numbers that we have to remove from the party. And so at negative 6 and at positive 1, I remove them and then I include everyone except for them. So from left to right, our domain would be from negative infinity to negative 6. And then we include the values between them because those are totally fine. And then we go from 1 to infinity. Okay, so now I think we have some square roots coming up next, almost there. So let's see what this one has to say. So let's try this one here. So again, in the numerator, there is no square root anywhere here. So the only thing you have to be aware of is division by 0. So we cannot divide by 0. But now notice in the bottom, I can actually factorize the denominator. You see the top can stay the same, but in the bottom, I can take out an x squared, yeah? That's the GCF. If I take out x squared from that, this is what I'm left with. And I wanted to see it factorized because now I know what pieces are telling me. For instance, that piece alone is telling us that x cannot be negative 14. And this piece here, this is telling you that x cannot be 0. Because if you plug in 0 there, it'll be 0. If you plug in negative 14, it'll be 0. So these are the two numbers that are bad. And so if you go like that, we're going to remove negative 14 and we're going to remove 0. And I always draw this little cartoon because this little cartoon helps me with my answer. So the domain would be from negative infinity to negative 14, union, negative 14, 0, and then union 0 all the way to infinity. So now finally we have one with the square root, which means we can have this discussion about not square rooting negatives. You see now for this problem, there is no danger of division by 0 because the denominator is just 1. So we don't even have to worry about division by 0. You just have to worry about not square rooting negative numbers. So what you can do is take the stuff inside. It says x plus 6. Take the stuff inside, and if you want, set it equal to 0 and solve. So that says negative 6. And all that means is that this is the number that makes the inside to be 0. So here's what I propose. Go to a number line and cut negative 6. Now, why don't we test some numbers? Let's test the number here, and let's test the number here. Pick a number that's on either side of negative 6. For instance, what's smaller than negative 6? Negative 7. What's bigger than negative 6? Negative 5. Let's test negative 7. If I plug negative 7 in for x there, it'll be negative 7 plus 6, which is negative 1. Can I square root a negative 1? I don't want to do that, so that's bad. So here on this side, everything before it is going to be bad. What about testing negative 5? If you plug negative 5 in there, negative 5 plus 6 is 1, and I can square root 1 because it's positive. So this side is good. So everything before was bad, but everything after was good. Now what about negative 6 itself? If you plug negative 6 in there, it's 0. Square root 0, that's okay. So for this problem, the domain would be negative 6 included. That's what the bracket means. The bracket means you include that number. And in this case, we're going to go to the right because we want numbers that are bigger than negative 6. And when I say go to the right, I mean all the way to infinity. So this would be the domain for this problem here. What about this one? Let's see. So here we have a couple of pieces, and let's look at the bottom. So here we're dividing by this. Now I have a question for you. Can it ever equal 0 in the bottom? The answer is no. Because if you think of any real number that's positive, and if you plug it in there and square it, it's going to be positive. If you plug in a number that's negative and square it, it'll be positive. If you plug in 0, it'll be 0. And that's just 0. So what I'm saying is, for this problem, for this specific problem, the bottom will never be 0. So we don't have to worry about division by 0. That's not a threat at all. The only thing you have to worry about for this problem is not square rooting by negatives. So let's just worry about the top. So that says x squared minus 9. Set that equal to 0 and solve. If you square root, it'll be plus or minus 3 because it was a square root. So what this means is we should make a cut at positive 3 and negative 3. And now I am going to test some numbers. I'm going to test the number before negative 3, after positive 3, and before. You see, these purple numbers are test numbers, and they'll indicate whether or not the region to which they belong is acceptable or not. For instance, can I plug in 4 into here? Yeah, because that'd be 16 minus 9 is 7. Square root 7 is okay. Can I use 0? No, because if I plug in 0 there, 0 squared is 0 minus 9. That's negative, and that's bad. Can I use negative 4? Sure, because if I square negative 4, it's 16 minus 9 is 7, and I can square root a positive 7 safely. So for that reason, everything here is good, everything there is good, and everything in between is bad, bad, bad.